Hello. That works now. Hi, good morning, everybody. It's exciting to see so many faces at a conference. This is really strange. I think for a lot of us to sort of be back in person at a conference. We're gonna get the opening ceremony started in just a second. Still just figuring out some technical details in the back there. But this is a hybrid conference, and so we're going to have participants remote, in person. I encourage you to connect to Discord. I'll tell you more about it in just a second. And you can discuss papers, ask questions, interact with authors that are remote as well as in person. This is sort of more of a persistent way to discuss a paper on Discord. Can we get the presentation video up, please? The opening ceremony presentation, sorry.
Tutorials, a remote cooperative
There we go. Okay. Okay. For remote participants, I'm going to stand here because there's a camera pointed at the podium. So, bienvenue à Montréal, Graphics Interface aussi. Welcome to Graphics Interface in Montreal. This is a beautiful time to be in the city. The spring in Montreal is just simply amazing. Everything's like turning green, and the weather this week has been exceptional. Hopefully the weather stays nice for our dinner tomorrow. And for those of you attending remotely, welcome as well. So this conference is brought to you by these fine folks shown on the screen here. I'm Sheldon Andrews. I'm going to hand off to my co-chair for the technical program, Deborah Fells, in just a second. And our conference general chair is actually also our technical support for the conference. He's easily the hardest working general chair I've ever seen. He's put a lot of work and effort into not only the technical aspects of this conference, but also organizing it. As well, we have our posters chair, Fatem, our workshops chair, Chital. The workshops took place yesterday. There were 3 of them, and they were fantastic. You could attend remotely and in person. And our hybrid chair, Leslie, who could unfortunately not be here, but I'm sure she's watching from home at the moment. As well, we have a small army of student volunteers that will be helping out with the conference. You'll probably see them from time to time. They're wearing these nice-looking hoodies, so they're easy to identify. If you need help with something, just walk up to one of them and ask them for help. So it's Laura, Kianchu, Samuel, Lancer, Guillaume, André, and Min. And of course, we couldn't make this conference happen without our sponsors. They really are essential for making this conference viable and keeping things like registration costs for students low. So we gratefully thank the sponsors for making this conference happen. In fact, I believe that there are representatives from several of the companies who have sponsored the conference that will be in attendance at GI over the next few days. So this is a good opportunity to walk up and talk to some of these people, especially if you're looking for a job. I know many of the companies will be advertising as well in the Discord channels, and there are some leaflets that have been included in your conference bags as well. So if you're out there looking for a job, this is a good opportunity to go out and sell yourself. So as I said, this is a hybrid conference, and there's 2 ways to participate: remotely and in person. And this is actually the first in-person GI since 2019, when it was held at Queen's, I believe. But this is a new experiment for us to do a conference hybrid, but also this is the first in-person conference since GI has done a conference on its own without the aid of the AI and CRV conferences. For those of you that remember the tri-conference setup that we had in previous years. But I think we have very strong attendance here. There are actually 174 registered attendees. This was the count yesterday, which I think is a very healthy number. And 95 of these attendees have flagged themselves as being in person. And so I'm sure we'll see other people arriving over the next day or so. And there are 79 plus virtual attendees that will be attending by YouTube and Discord. Here are some statistics about the technical paper sessions. So this year we had 52 technical papers submitted to the program, and of those we accepted 25. This is roughly a 48% acceptance rate. 7 of these were graphics papers, and 18 were HCI and Viz papers. And interestingly enough, all of those graphics papers were accepted during the second submission deadline. Yeah. Right after Christmas deadline, exactly. And there's representation here from all over the world, all over Canada. So we have attendees here from BC, Alberta, Saskatchewan, basically all the provinces in Canada. International attendance as well from across the globe: Japan, China, France, Saudi Arabia, Austria, US, Sweden, and strong industry and academic participation in the conference. So we're very pleased that there's quite a number of submissions from all over the world this year. Some logistics about the remote participation for those of you viewing remotely that want to participate in the discussions that happen after each paper presentation. You will be able to watch on YouTube the live feed for all of the invited speakers and technical paper presentations. And if you have a question, you can pose it on Discord. And what's going to happen is that one of our student volunteers or one of the chairs is going to approve the question. Just going to give it a thumbs up. So if you see a thumbs up in your question, that means it's been approved. And then anybody can go and upvote a question. And we actually have a script that's going to scrape that information off Discord. It's going to show it up here in the room as well on the live feed. So you can see the questions that are being asked during each paper session. And then once the question has been asked, a moderator is just going to flag it as done. So if you see an X next to your question, don't think that we don't like that question. It just means that the question has been addressed or it's been asked, and so our script will just automatically take it out of the list. And so this is all going to appear automatically in the live feed. There's a paper session, there's a channel for each paper session, as well as for each invited speaker and keynote and award talk. So you can go in to each one of these channels and ask your questions that are specific to papers or talks in those sessions. As well, we encourage you to use Twitter, tweet out about the conference, tell us about how much you're enjoying the conference, take pictures and share them. So you can do this via Twitter and our Twitter account. Just some logistics about the sanitary guidelines. So up until roughly less than a week ago, I think, it was mandatory to wear a mask inside buildings in Montreal, but it is no longer required. However, if you do wish to wear a mask, that's absolutely okay. There's surgical masks and disinfectant stations that are available all over the building. We have some up in the back as well. And of course, if you have symptoms of COVID, just please stay home. If you're having trouble connecting to the Wi-Fi, if you're attending in person, here is the information that you need to connect via Wi-Fi. I've also blasted this information out on the Discord channel, so in the announcements channel, I sent that information. So this is what you need if you want to get connected to the Wi-Fi. Or if you're a researcher attending from another university, you could just use Eduroam. Just use your Eduroam account. So graphics interface is not just about technical paper it's not just about technical paper presentations and posters, which we'll talk about in just a second. It's also about celebrating the excellent work that's done in our community. And so GI has traditionally done that in several ways. One of those ways is through invited talks and keynote speakers. So we have an excellent lineup of keynote speakers, as well as the awards program, which Deborah's going to talk about in just a second. But we have 2 keynote speakers lined up for this conference. One of them will be happening today. Super excited about both of these. Yornay will be here in person to present later this afternoon. Yornay is from USC and Ziva Dynamics. And Sid Fells, who's from UBC. Unfortunately, he has to change to a remote presentation at the last minute, but he's going to present on Wednesday. As well, we have 3 invited speakers. We have Jian Zhu from Waterloo University, who's going to be presenting tomorrow. As well on Thursday, Anna Huang from Google Brain will be presenting, as well as Justin Solomon from MIT will present on Thursday as well. I think Justin and Jian will present in person, and Anna will present remotely. I mentioned the awards. I'm going to turn it over now to my co-chair, Deborah, and she can tell you more about the awards.
Hi. Thanks, Sheldon. Okay. Hi, everybody. It is so nice to see you in person. It's really wonderful. And so you might be wondering, Sid Fells, Deborah Fells, we look like each other. We're family. He's my brother. I'm his sister. So, you know, keep it in the family, I think. All right, so one of the other ways that GI celebrates excellence and you know, contribution is through a couple of different types of awards. One of the ones being awarded this time is the Achievement Awards, one in graphics, one in HCI, and they're being given to Richard Tsang and Porang Irani, and I'm sure all of you know at least one of them, if not both. And they will be presented in the morning on Wednesday and Thursday, and they will be giving a 45-minute talk for that, for their award. These awards are a nomination-based system, and it's, you know, evaluated by the awards committee from CHCCS. So that's done earlier in the year, and if any of you are thinking about 2023, you may want to consider nominating somebody for those. Okay, the next type of award is the Early Career Research Award, and that goes to people who have been in the discipline for less than 5 years as a academic. These are academic awards, and the HCI one is going to Sarah Nabil, and the graphics one is going to Manolis Sava. And I'm sure you know these people as well. They've been around for a little bit of time, but we've seen them a lot as graduate students. And then the last two awards are the Alain Fournier Award and the Bill Buxton Award. Bill Buxton is for the HCI Award, sorry, and the Fournier Award is for the GI, and that's going to Ryan Goldale, and the Bill Buxton Award is Xing Tong. Xing will, unfortunately, is stranded in Shanghai, and they're not letting her leave her apartment, never mind the country, so she's going to be a remote talk. And they have 30 minutes to present. Okay, I'm going to give it back to Sheldon, who knows a lot about this particular fun thing.
Sure, thanks, Deborah. Whoa, okay, it's a bit loud. So after the poster session that's happening later today, and after the welcome cocktail, we will have a special showing of the electronic theater from SIGGRAPH 2021. They opened this up just for us to show it again at GI. I'm pretty excited about this because I actually didn't get a chance to see it at SIGGRAPH this year. And so we'll be showing that later today at 6:15. We'll start the showing at around 6:15. And so that's unfortunately only for in-person attendees. It'll be done in this room. And it's fantastic. I look forward to this every year at SIGGRAPH, but like I said, could not, unfortunately, watch it this year. So I'm excited about that. Tomorrow night, there will be a conference dinner, and we'll be just walking a short distance down to Brasseur de Montréal. And this is about a 10-minute walk away, so people can leave here together in groups, and we can walk over there. This is a nice venue. It's got like an open area, like a covered open area, so we can go out there, hopefully, if the weather's nice. It's a very relaxed, chill environment, so a really good opportunity to do some networking and socializing. And now I'm going to turn it over to Fatem, and she's going to talk about the posters.
Okay, thank you so much. I'm Fatima, and I was the poster chair. I've been in contact with many of you, I believe. We have 20 exciting posters this year accepted. 8 of them will be remote, so you will see some laptops, tablets running around. It's people who are presenting remotely. but we printed the poster. So you will see the printed poster, and then you get the chance to talk to them on tablet. And this is this afternoon at 5 p.m., just right out the door for in-person sessions. And then we will have another one which is virtual, and that will be tomorrow at 5:15, and it's on Discord. So if you're a poster author, you will probably you will see one channel allocated to your poster, and that's for you to talk to people who are remotely connecting. So hopefully it's clear enough, but just bear in mind that you have 2 sessions to attend as poster authors and also as attendee. If you wish, you can attend the virtual one as well. We have HCI posters, Viz, and graphic as well. So we'll take advantage of all these sessions, and we're excited to have you. And just to get you started, we have fast-forward sessions for posters. It's going to be played out here as a video, and you will get a chance to know what are each posters about, and then you will go outside and talk to the authors if you wish. Okay, Adrian, if you can please play the poster.
Recent work has proposed a domain decomposition approach for breaking down complex rigid simulations with context into smaller partitions that may be solved in parallel. The approach reduces wall clock simulation time without sacrificing accuracy. However, for unstructured simulations, both is frequently form and break context. Therefore, an efficient algorithm must be used to traverse constraint graph and decouple the simulation into smaller contiguous systems. We evaluate several efficient graph partitioning algorithms and even propose a new partitioning algorithm that outperforms the algorithm proposed in the previous work.
Unstructured text data is ubiquitous in news media data. There's an unmet and increasing need to explore, analyze, and understand large quantities of media data. Untangling entities and their relationships as they change over time presents unique analysis challenges. We present our in-progress work on co-designing a visualization tool to address these challenges and help users explore narratives from different perspectives. Using focus groups and interviews, we are gathering design requirements and defining visualization tasks.
Older adults are facing major issues using these applications due to their lack of understanding of the technology and hesitation to adopt them. In this work, we examined the adoption of mandatory pandemic tracking application among older adults. We observed that using pandemic-related applications by older adults on their own is difficult, and designing these applications need to take into consideration the challenges older adults face in the future.
The rise of blockchain technology led to the quick integration of its techniques in online games. To understand players' experiences using cryptocurrency in games, we conducted an online survey with gamers and examined different crypto games. We found that players are hesitant to explore this genre of games due to lack of awareness, uncertainty, norms, and acceptability. Our initial results illuminate opportunities for better integration of cryptocurrency into games.
There are over 50,000 strokes in Canada annually, and adherence to rehabilitation programs is key to recovery. In this project, we aim to design and develop an interactive data visualization tool that will display health data of patients recovering from stroke to enhance patient engagement in their rehabilitation program. Currently, we are conducting interviews with the stroke rehab healthcare team to identify the design requirements for our data visualization.
Why are you wasting time computing deformation on undeforming elements? We figured out how to adaptively reduce non-deforming regions to rigid bodies. Treat yourself. Let the program choose what should be rigid and elastic at runtime. Get rid of the hassle of picking specialized speed-up techniques. You really only need one. Come and see our poster session to learn how to simulate physics-based animations more efficiently.
Implicit surfaces allow you to mathematically define a broad class of exotic shapes which you can't represent explicitly. We devised an algorithm to efficiently render such surfaces by subdividing space using interval arithmetic, while locally approximating the implicit function at each subdivision. This builds a sparse octree structure, which we can then efficiently update as the surface moves in time.
We propose an optimization-based framework for automatically aligning and stitching grids of microgeometry scans from a tactile scanning apparatus, as shown here. Geometry is encoded as normal textures with sub-micrometer precision, and a gradient-free optimization technique minimizes the surface normal orientation difference in overlapping regions. Our technique is better at preserving salient features in the texture compared to baseline algorithms. We use our technique to assemble grids of up to 77 textures. Please, come visit our poster for more details.
How do you order a drink if you can't be understood? Radial AAC is designed to help speak for you. It has a simple radial menu that makes scroll through order selection relatively fast and uses voice to text.
Hello, I would like to order a medium limonada, please.
Let's not get stuck on speech. Let's get more out of life.
Feel. Color blue. Color green. Eraser.
Hello, this is my demo for the PainBit tracker meant for chronic pain tracking. So we can see some of the functionality of this circuit. Initially, there's a calibration where for each level, we enter the level of force, which calibrates it for level 1 to 10. And then once the calibration has been completed, now it can detect the pain level based off of the pressure applied and store it into the system to be ready to be visualized and for patients to see their data. That is it for my presentation. Thank you.
We propose extending electrovibration to clothing and wearables that stimulate different parts of the body, also to smart objects such as a keyboard that stimulates the palm, which seems to respond quite strongly to electrovibration. We conducted a psychophysical study to compare the perception of electrovibration on the fingertip and the palm. Our results reveal that the palm is very sensitive to electrovibration, and that our concept of an electrovibrating keyboard should produce strong and rich tactile sensations.
We propose the use of in-situ visual feedback on the user's hand to indicate how to complete a gesture in virtual reality. This allows users to understand how to position each finger more precisely and hit a smaller target in gesture space, making it easier to define additional gestures later on. In-situ feedback can also be used by a system that infers and auto-completes a user's intended gesture. 4 variants of our feedback are demonstrated.
Programmatic visualization systems define notations for the specification of visualizations. We introduce Notoscope, an approach and tool for evaluating such notations using the Cognitive Dimensions framework. Notoscope models the cognitive dimension of viscosity as the edit distance between 2 specifications in a given notation. These distances are used to generate interactive network visualizations for a corpus of specifications, which can then be examined to evaluate the notation.
Just want to say thank you, and please come at 5 p.m. for the poster session.
Thanks, Fatima. Okay. Yeah,
Deborah?
I'm going to go over here.
Okay.
I'm just going to shut this. Oh, okay, never mind. Now I get to go to the seat. Oh, not with this microphone, though. I feel very media-like, talk show host. Okay. Right, good. So I am going to be chairing the first session on supporting learning, is the title of it. There are 2 papers in this session, and they are both virtual for different reasons. And my Shital is going to help with the Discord because I didn't bring my phone. So the paper is going to be presented via video, and then we're going to do the question and answer session via Discord, and I think Sheldon gave the instructions with respect to how that's going to work with check marks and X's and thumbs up. Everybody okay? Anybody have any questions about how that's going to work? We sort of did it this way last year, only when it was totally virtual, didn't we? Yeah. Okay, so are we ready? All right. So we have the first paper. Who's going to be presented?
Tutorials, a remote cooperative tutorial system for 3D design software. Step-by-step tutorials have emerged as a key means for learning complex software, but they are typically designed for individuals learning independently. In contrast, cooperative learning, where learners can help each other as they work, is a fundamental learning technique with many established benefits. In this work, we are interested in how the benefits of cooperative learning can be made available on demand to remote learners of 3D design software, and to extend the benefits of over-the-shoulder learning to users who would not be able to benefit from it otherwise, for example, users who are learning at home, either informally or through online courses. Prior work has demonstrated the benefit of step-by-step tutorials, as well as systems that allow users to learn in the context of realistic tasks. Harnessing community-created content, such as multimedia demonstrations of tutorial steps or comments on tutorial content, has shown to be a beneficial approach in learning software. To provide an active learning experience, some prior work on software tutorial system has also integrated elements from games. Remote learning is becoming important nowadays. The global coronavirus pandemic has demonstrated the need to establish effective remote learning environments. A key question raised in this context is how to enable remote learning that preserve the social aspect of in-person learning, giving learners opportunities to engage and interact with each other. Currently, there exists no step-by-step tutorial that explicitly support remote cooperation. To fill this gap, we built on this body of prior work but focused on supporting active cooperative approaches for learning 3D design software with other users, and proposed the first known step-by-step tutorial system specifically designed to support remote peer learning. To inform the design of our system, we conducted an observational study of dyads of participants working on 3D design tutorials together in a range of different learning setups. Our study addresses the following research questions. What are the salient components of cooperative learning for step-by-step 3D design tutorials, including potential benefits, challenges, and common strategies? What are the appropriate design principles and interface features to support these components? To gain a broad set of insights into the benefits and challenges of collaboration, we tested 4 cooperative tutorial setups: co-located shared workspace, distributed shared workspace, co-located separate workspace, and distributed separate workspace. In this study, each dyad of participants completed 2 tutorials across one of these axes. Our results shows that both separate and shared workspace shown advantages and disadvantages. Having a shared workspace forced the peers to collaborate, which was beneficial, but created a situation where the participants that was not driving the system could become frustrated and feel like they were missing out on learning. Our study also revealed a range of challenges to coordinating efforts when participants were distributed. However, when co-located, it was much easier for participants to make spatial references to parts of the 3D environment and to assist one another by looking at each other's screens, pointing at parts of their peers' screens, or even taking over the mouse of their peers to make simple changes to 3D objects. In terms of the benefits to cooperative learning of 3D design software, participants reported having an overall positive experience and suggested that this approach allowed them to gain additional insights beyond the tutorial content. Our observations and interviews indicated several common strategies that peers use to cooperate with one another. During help-seeking instances, we observed that participants in distributed setup started by establishing common ground and shared 3D context with their peers as a first step when providing assistance. Finally, we observed several challenges that can come from working cooperatively on step-by-step tutorials for 3D design software. For example, participants struggle to maintain awareness of each other's activities due to lack of shared context. The results of our observational study suggest a set of 5 design principles for cooperative step-by-step tutorial systems for 3D design software. Systems should help establish and maintain shared 3D context between peers. Systems should balance the need for independence while also encourage collaboration between peers. Systems should provide learners with high level of awareness of their peers. Systems should provide non-disruptive communication modalities. And finally, systems should encourage peers to work together and synchronize their progress through the tutorial setup. Guided by these design principles, we developed tutorials, a cooperative step-by-step tutorial system designed for peer of learners. In tutorials, each remote peer gets an individual workspace as well as access to the constantly updating and editable view of their peers' workspace. Enable users to observe their peers and actively assess them if needed. Peers can communicate, help, and encourage each other using both verbal and nonverbal communication modalities. The system also provides implicit awareness cues to help learners maintain awareness of their own progress in the tutorial and whether their peers are falling behind and may need help. Finally, users can also send predefined visual messages that provide simple, non-disruptive communication between peers. To evaluate tutorials, we conducted a study following a within-subject mixed method design with 6 dyads. Each dyad of participants completing 2 step-by-step tutorials, one using tutorials and one using the baseline, the Tinkercad built-in tutorial interface. At the start of the study, the system were introduced and the available cooperative features were explained. After completing each condition, a set of questions were administered on the overall experience, ease of following the tutorial, learning, usefulness of the cooperative features, and cognitive workload. Our results shows that dyads spent significantly less time on completing the tutorial together using tutorials compared to the baseline. These findings provide evidence that the features of tutorials help participants to complete the tutorial together more quickly. For the cognitive workload results, we found significantly lower ratings for effort, mental demand, and frustration for the tutorial condition as compared to the baseline condition. These findings provide compelling evidence that the features of the system help reduce the cognitive load on participants. For each condition, we asked participants a set of questions on what they learned from the tutorial experience. For most of the questions, we found no significant difference. However, the statement, "I learned something from this tutorial," favoring the tutorial condition over the baseline condition. We also asked participants a set of questions on different aspects of their experience with the tutorial, maintaining awareness of peers' activity showing to be significantly higher in tutorials as compared to the baseline. We asked participants to rate the usefulness of the individual features in our system. Participants generally reported the features to be useful. There was strong support for the voice chat, the ability to view the peer's workspace, and the ability to directly edit the peer's workspace. Participants also reported being able to coordinate with each other more effectively using our system, with smoother information flow between peers. Also, the system created an environment where cooperative learning was supported. Finally, participants reported enjoying the cooperative tutorial experience in both conditions and found it to be engaging. Overall, our evaluation indicated that tutorials help participants to engage in cooperative learning, improve their performance, reduce effort and mental demand, and help participants to maintain awareness of each other's progress in the tutorial. Future work should look into how to better match peers of remote users to work together on tutorials. Our results suggest that it may not be a good idea to match users with large differences in overall experience, which could result user becoming bored. Instead, The system could try to match users who are at similar levels of experience but have complementary skill sets through using skill-based matchmaking mechanics. Although we focused on step-by-step tutorials for 3D design software, we believe that the features of tutorials could be easily adapted to work in other software domains with strong visual elements such as photo editing or the creation of games. This work has demonstrated an approach and a set of features for creating cooperative remote software tutorial system. Our findings indicate that participants enjoyed the cooperative learning experience that this approach enabled. Overall, we see this work as a first step toward a future where anyone, anywhere, can gain the learning benefits of working alongside peers on interesting and engaging projects. Thank you to all our amazing collaborators on this project.
Okay. Thank you. And we have Sultan, who is available now live.
Hey,
and,
good morning, everyone.
Thanks, Sultan. All right, so now is the question and answer management time. So first, we have questions from both places, potentially from the live audience here and on Discord. So why don't we do the live audience first? Sorry about virtual people, but that's the way it is. I'm going to give you a microphone. Can I? Oh, you got one. Okay. So any questions from the audience in the live world? Okay, come on, you guys that are teaching graphics design.
Hi, thanks for the really interesting research. That was a great presentation. I'm wondering if this tutorials feature is available online in Tinkercad now, or if there's plans to launch it to the public.
Well, this is a great question. I wish it's available right now. So this was done in 2018 during my internship at Autodesk. So a lot of the insights definitely will be probably investigated more and see if that is going to be part of the commercial Tinkercad kind of 3D design software or not. But definitely all of the benefits of the 3D design cooperative learning would benefit a lot of the students and also learners of 3D design, especially now with the COVID-19 situation.
Absolutely, yeah. Tinkercad is a really great learning tool, so I hope to see your work out there for people to use. Thanks.
Hopefully. Thank you.
Anyone else?
How's our, sorry, I didn't bring my phone. How's the Discord questions? Do we have any? Yeah, I know I forgot my phone too. It's over there. Okay. While that person's typing, I actually have a question. So as an instructor, one of the things that's important to me is to be able to offer students learning stuff that's maybe in the lab, TA support. And how would a TA, a teaching assistant or an instructor be part of this learning activity so that they could either monitor it or give some help or whatever? Could you add a third person who's maybe operating at more of a supervisory level?
That's a great question. Definitely something we looked at the tutorial system design itself. I think remote learning, it doesn't need to be peer learning. It can have also some kind of a supervisor or an advisor or even a tutor or a TA that can oversee the students working together, or if they need any help, they will jump in and assist. But definitely as a first step, we were looking at two peers, remote peers, whether they are two students learning the same tutorial or even a more advanced kind of a TA who wants to try to help another student. So we do have one feature that actually help in that way is that it's a measure of how much connection or interdependent teachers need to be at the same level of the tutorial. We can have low or high kind of dependencies, whether the peer need to finish the tutorial first to move on, or they need to wait for their peer to finish also with them, and then they both move to the second level of the tutorial. So these kind of interdependent levels can also play a very important role in helping them collaborate with each other. But a TA or a assistant will be a third kind of person to be added to the learning dynamic here, which would be interesting to add also. But right now, tutorials is more about the peers learning together in this situation. Yeah, but future work will look into adding probably a third or a TA or someone who oversees the learning experience itself.
Okay, thank you. So we have, we have a, yeah, we have, but hang on a sec. Let's see who has, we have a question here from our virtual audience. It's any pessimistic behaviors that you think cooperative learning might encourage? So negative behaviors. Did you notice any sort of, things undesirable happening during these sessions?
Definitely, that is a good question. Also, we noticed that some of the learners did not want to kind of share a lot of their kind of skills sets or even help. Having the access to the other peers' workspace and being able to edit it is something that not everyone liked it, because you don't have to have permission to do that. You already have access to their workspace, and you can even edit without their permission. So I think a new, like an advanced feature is that we can give permissions or not to the peers to change our own workspace or not. So sometimes cooperative learning or even peer learning is challenging, especially if the motivation to learning is not there. So we have to think about how people are learning, usually in cooperative settings. If that is an advantage for them, such tutorials would be beneficial. If not, then probably single tutorial or a individual tutorial will be better for them. So different learning styles definitely need to play a role in selecting tutorials.
I think everything should be purple, so I don't really care what you think the other color should be. Sorry. Yes. Okay. And maybe we'll have one more question from the live audience. Thanks.
Thanks for the presentation. I have one question about your user study. I think in your study for this distributed setup, the participants were still co-located, but separated by a divider or something. So they could still talk together. Do you think your voice chat feature would work the same if the users are not co-located?
Yeah, definitely. We had the partition as a proxy for distributed, since the setting itself was not possible to do distributed. But the voice chat in this case did not help. They will hear each other through the divider, definitely, which will work as a voice chat. So we turned off the voice chat through the system itself. They were talking with each other as if they are using a voice chat itself, which affected the text chat. So they did not use the text chat at all, because voice usually override or overpower all the communication modalities. But what we noticed is that they used the peer pings and also the annotations techniques to communicate with each other on top of the voice chat itself. Yeah.
Okay. Sultan, thank you so much for a wonderful presentation, and it was interesting, and thank you for being live with us to answer some questions.
Thank you so much.
Thanks, Sultan. Okay.
Hello, thank you.
Okay, our next presentation is is by Carmen Hall on Simultaneous Worlds. Thanks.
Hello, and thank you all for attending this session today. I'm happy to present to you a project called Simultaneous Worlds, where we take the well-established use of physical scale models in architecture and identify new opportunities for using them to interactively visualize multiple streams of data. Our initial findings show that the models provide a powerful referent for understanding visual encodings in a variety of different ways. We considered 4 design challenges that have been identified when exploring spatial datasets. Many datasets are generated in a specific physical context, but are seldom shown that way, in part because overlaying, comparing, or combining visualizations in 2D space can be problematic. As a result, much of the relevant contextual data remains unrecorded and therefore unconsidered. On top of that, the large scale of community or urban datasets can often make observation difficult, especially over timeframes spanning multiple days or even years. In response, we introduced the concept of simultaneous worlds, in which architectural models and data visualizations inhabit the same physical space, inspired conceptually by the work shown here by M.C. Escher. There are 3 distinct worlds, shown here layered in the same view. You see the reflection of the trees on the water, the leaves floating on the surface, and then the fish contained in the water beneath. And so to explore the potentials of this concept, we built a layered, tangible tabletop system using scale models of a university campus to anchor different types of both spatial and non-spatial data types. We used a research through design framework where we documented our iterative design process and ongoing conversations with the energy managers, building and operations managers, as well as students and architects. We built and revised 2 different interactive tabletop systems, one a prototype, over the course of approximately 2 years. And so specifically, we examined 3 avenues via which physical architectural models can support data exploration, and we showcase the benefits that they provide. This can include situating data, which improves the viewer's ability to identify locations and then connect the data to them. We highlight how visualization developers can use models to anchor composite views that combine multiple data sets and visualizations in the same space. And then we show how physical models can support fluid and tangible interactions, which allow viewers to explore and reconfigure spatial visualizations. We also illustrate these concepts with 2 data analysis tools, one which uses our system to visualize campus climate and energy use, and one which visualizes human movement across the university campus. We started exploring these concepts with a bottom projected tabletop, which we built to accommodate a 26 by 46 inch, 1 to 1700 scale architectural model of a university campus that was about 2 1/3 square kilometers. This image shows the system diagram on the left and the conceptual mapping on the right, where different data types, such as historical images, heat maps, vector-based graphics, such as building footprints and networks, and also physical models, can be layered simultaneously. The physical table consists of a short throw projector, a laminated screen with a base map etched into the surface, and a frame made of 80/20 building materials. Our system uses a series of distinct acrylic models placed on the illuminated tabletop. We constructed each model using a mix of digital fabrication and hand building techniques. The unique outline of each floor plate for each of the buildings was laser cut from a 1/8 inch acrylic sheet, which also conveniently happened to be roughly equivalent to the scale of the building floor height. We then stacked and glued these layers together with a clear adhesive. To track each building on the tabletop, we developed a custom tracking system using a Microsoft Kinect V2 and OpenCV3 on the Unity game engine, with reflective markers as tracking devices. Our first visualization cycles through daily heating and cooling costs of each building, with a second color ramp in the backdrop showing the temperature, highs, and lows for each day. We also etched the surface of the tabletop to include the footprints of each building, along with roads, parking lots, trails, and other important orientation elements of the campus layout. Due to the translucent and internally reflective nature of the acrylic, the visualizations displayed on the surface reflect up through the building masses, filling the volumes with the encoded color. Throughout the design process, we systematically consulted with domain experts, including campus operations and energy managers, and architects at major project milestones. During these meetings, we would collect reflections, framings, and identify opportunities where we could use these to guide our research work. And this resulted in a set of framings and prototypes that more deeply illustrated the potential of architectural models. Shown here is our first smaller prototype that we put on a Microsoft Surface that was used to collect feedback with periodic rounds of semi-structured interviews and informal demo sessions. We demonstrated this system publicly about 7 times during its development, including as part of a citywide art and science festival, at department and educational showcase events, and during lab demo days. We implemented 2 visualization systems for the model. The first is an energy use visualization developed using processing, which combines building automation logs and ambient weather data from the university campus collected over a 2-year period. To track the position of the buildings on the tabletop, we used a custom tracking system and a sandbox area for seeing more granular data. The process estimates the total number of tracked buildings on the table and outputs positions and IDs for each building, and then it will update events depending on whether the building is moved or changed position. Once the second system was finished, we wanted to understand how the presence of physical models might impact viewers' ability to interpret the campus layout, and we conducted a between-subject study with 16 participants. We asked each participant to use either a map or model to identify campus buildings, giving each person 2 minutes to identify and name as many buildings as possible. The result from our model study suggests that participants who had access to the model on top of the map were able to more accurately identify campus buildings. Individuals in the model condition reported that they were able to rely on the heights of the buildings as well as their visual signatures, allowing them to more readily align their mental model of the campus with the representation on the tabletop. One participant in particular noted that the model helped her see what she could see every day. In addition to the more specific input from our domain expert collaborators, we also maintained and updated a working set of top-level research themes, which guided our prototyping efforts and prompted our exploration of what potentials architectural models could be used to support situating, composing, and manipulating and authoring new visualizations. These approaches would allow new designers to create composite visualizations that can encode a more diverse combination of data while also creating a strong association between the components of the physical model and the related visualizations, therefore reducing the need for labels and annotations. So specifically, we examine how models and their subcomponents can anchor, bound, and define the geometry of visual marks and provide new opportunities for integrating multiple simultaneous views. The second movement visualization showcases location data from several hundred university students collected between 2013 and 2017. With this visualization, we explored the use of models as graspable tokens, which viewers can use to interactively control views and author new visualizations. Depending on the scale and level of detail, models can also be broken down in a variety of different ways. For example, in a reveal interaction, picking up a piece of the model can be used to hide or show information underneath in the visualization, or conversely, in an assemble interaction, repositioning pieces of the model on the map can serve as a mechanism for constructing new visualizations. Our ongoing process of design, reflection, consultation, and validation surfaced a variety of implications for future systems that could integrate visualizations and architectural models. While we have discussed the potential for simultaneous worlds in the context of architectural models, we also highlight how the concept may hold promise in other application domains. We discussed issues of models and data granularity, optimizing city-scale systems, how to collaborate around scale models, and what you could do to use scale models for exploration and simulation. In summary, our explorations detail how physical models offer new potential for supporting observations that can integrate contextual and ambient information from multiple simultaneous worlds. Through both our design explorations and reflections on the development process, We hope to lay the groundwork for even richer integration between visualizations, models, and interactions, including ones that extend beyond the context of tabletops. As well, we hope that this work can provide inspiration for other forms of physical data models that support situated and embedded visualizations with embodied and fluid interactions. So thank you everyone for listening, and I look forward to any questions that you might have.
Thank you. Hi, Carmen. Nice to see you.
Hi. Thank you.
Thank you for your presentation. That was really fun. Move it here or something. Okay, try again. All right, so the floor is now open for questions. We don't have anything yet. Any questions from the audience in the live group? Okay, I have a question. So these models, when people were working with them, had mostly looked like a bird's eye view. They were looking on top, which is not usually how we look at buildings when we're looking at buildings, maybe when we go in the helicopter. So did you notice whether people were having a hard time with that bird's eye view and whether they started to try and look at the sides or wanting more of a street view? And I know people in architecture tend to be more familiar with the bird's eye view method because they kind of do that. But did you notice that?
Well, what's hard to get from the videos and from the camera view is that the tabletop is actually set at more of a bar height. So when you're approaching the table and when you're looking at the models, you actually do see more of an angled view. It's not as, you don't actually see quite a bird's eye, like more top down, really. So you are, and the scale is quite large. So the entire tabletop is about the size of, you could fit two people on the long side, one person on each end, and then two people on the other side. So the scale is really quite large. So you're able to really immerse yourself in the model at that scale, which we found was really useful. And the way that we could tell this is that, especially in the model study, when people were going through the campus, they were describing their mental model of the map and how they experience the campuses in their memories. So they say, okay, I start here at this parking lot. There's this building. There's the library tower. So they would remember their own perspective as they walked through the model. Whereas when we were doing the study with the map view, it was more of an abstract recollection that people would describe, and they were more trying to identify buildings from their memories of using other maps as opposed to their own experience. So I think the scale of it is really important, and you want it to be large enough that you can sort of project yourself into the model, but not, but you still want it to be on a tabletop setting. So seeing it in person, it has a really profound effect over seeing it in the video. Yeah.
Imagine, yeah. Thank you for that explanation. All right, we have another question.
All right, test. So Michael McGuffin, I'm a professor at ETS. So one way we can imagine extending your work is having the users wear an augmented reality headset. And we can imagine like virtual sticks coming out of the buildings with maybe tool tips or extra information. And I've done a little bit of testing with the first generation HoloLens, and unfortunately, there's some imprecision in how it positions things. Usually we can't get much better than 3 centimeters precision. But maybe we can imagine that we have perfectly precise positioning of stuff. Do you have any thoughts about maybe combining your system with augmented reality headsets or other technologies?
Yes, we absolutely considered that. And we decided to just use the more raw, tangible interaction piece first to look at the potentials of that system, because that hasn't been researched as much. There are currently quite a few studies that are using AR or VR, and we do consider this an augmented reality system because it is using a lot of projection and digital augmentation. But we did want to explicitly explore the strengths and the potentials of using these tangible physical models, because there are also a lot of studies in other realms, in other domains, where that tangibility actually has a profound impact on memorability, engagement. And so we wanted to test that piece before we went into the more virtual or augmented with headsets. I think that there's so much potential in that area. There's no doubt about that. But there's very little research on physical models on tabletops, especially touch pieces. So we wanted to explore that piece first with this iteration. Yeah,
thanks.
Thank you.
Thank you, Michael. Thanks, Carmen. Right. So any other questions that we have? Sorry. Just looking on our Discord. I think it comes up here, doesn't it? I'm not sure what time it is, but we're probably pretty close to the end of the session, regardless. Do you have a question? Sorry. Okay, good. Then I think we'll thank Carmen very much for your fun presentation and answers to the questions. Sounds like there's lots of fun things that can be done soon.
Great. Thank you so much.
Thank you. Okay, that closes this first academic technical paper session, and we will now move on to, I believe we have a break. Yes, we have a short break for some yummy things out there. And then we'll be back for our keynote speaker. So we'll see you in 15.
Let's get this second session underway. Hello, everyone. My name is Jean-François Lalonde. I'm a professor at Université Laval in Quebec City. So it'll be my pleasure this morning to be chairing in this nice chair, this session called Image Labeling and Features. So in this session, we'll have 4 papers. The first paper is titled An Empirical Study on the Effect of Quick and Careful Labeling Styles in Image Annotation. The authors are Chia-Ming Chung, Shi Yang, and Takeo Igarashi. You can start the video, please.
Hello, everyone. This is Chia-Ming Chung from the University of Tokyo. Today, I will talk about our study, an empirical study on the effect of quick and careful labeling styles in image annotation. The research background of this study is giving a label to ambiguous data takes a lot of time, particularly when non-expert annotators try to select the best possible label. And our research question in this study is, can labeling style improve label quality during annotation? And our answer is yes. Now let me show you how. In this study, we conducted an empirical study to understand the effects of label quickly and label carefully labeling styles in image annotation. We compared the 2 labeling styles used in an image annotation task. And then we use the data collected by the 2 labeling styles for machine learning. Then we compare the machine learning result to see the difference. In the image annotation part, we conducted a user study to compare 2 labeling styles in image annotation task. In the label quickly style, the user was asked to select a label for an image as quick as possible during the annotation. We asked the user not to try to minimize errors, but giving weight to efficiency. On the other hand, in the label carefully style, the user was asked to select a label for an image as careful as possible during the annotations. And we ask the user try to minimize errors by selecting the best possible labels. And in our user study, we use 3 different data sets, MNIST, Bayesian MNIST, and the Kuzushiji MNIST. The reason for using these 3 datasets is because these 3 datasets have different difficulty levels, and we want to explore the effects of labeling style in different data difficulties. MNIST is easy, Bayesian MNIST is difficult, and the Kuzushiji MNIST dataset is very difficult. We recruited 24 participants for our user study, 12 for the label quickly task, and 12 for the label carefully task. The labeling task for each participant is to label 100 images for each dataset. So each participant needs to label 300 images in total in the user study. These are the labeling interfaces for both label quickly and the label carefully style. The only difference between the 2 labeling styles is the interface for the label quickly style contains a timer here. So users are asked to select a label for an image within 5 seconds. However, the label carefully style has no time limited in the user study. And here is a demo video of the label quickly task. So I'll show you. So you can see there is a 5-second countdown timer here. And the user need to select a label for each image within 5 seconds. So this is the label quickly style. And this video shows the label carefully style. So there is no time limitation. User can take their time to think more carefully before select a label to this image. So they can compare if they are not sure about these images. So like think carefully before select a labels. And we measure the time and the accuracy rate of the labeling task completed by the participant. The annotation result shows that the label carefully style requires longer time than the label quickly style to complete the labeling task. When the images are difficult, fashion amnest, and very difficult, position amnest. However, there is no significant differences between the two labeling styles when the images are easy. The result also showed that the label carefully style can increase label quality. However, only when the images are difficult. There were no significant differences between the two labeling styles when the images are easy and when the images are very difficult. So this means that it is a waste of money and time to conduct a label carefully task when the images are easy and too difficult. And our questionnaire result shows that the labeling style did not affect the subjective impression of the participants' confidence. However, the data difficulties do affect the confidence of the participant. In the machine learning part, we run a machine learning experiment by using the data collected by different labeling styles. We use the collected data as a training data for the machine learning evaluation. And we use 3 common machine learning algorithms for the machine learning experiment. However, we did not use more advanced techniques such as deep learning because the training dataset was too small. And the machine learning results showed that the data collected by the label carefully style can improve machine learning accuracy when the images are difficult. This study has 3 main contributions. First, we identify labeling style as variable in non-expert image annotation and machine learning. Second, we conducted an empirical study comparing quick labeling and the careful labeling styles, and it shows the benefit of the careful labeling styles in an image annotation task. Third, we run a machine learning experiment using the labeled image by different labeling styles, and it shows the effect of labeling style in image classification accuracy. Finally, there is a limitation in this study. The limitation is we found that different labeling style brings different benefits. However, design an appropriate labeling style for annotators is difficult. It is because that different annotators have different experiments and domain knowledges. For example, user 1 may feel data A is easy, but the user 2 may feel it is difficult. So in the future, In the future, we would like to explore dynamic control of labeling style during the annotation task. Thank you for your attention. Any questions?
We do have time for a few questions. Are there any questions from the audience, please? There's one over in the back to the left.
My question is, a participant during the user study had 5 seconds to select an item, right? So why did you give them 5 seconds?
Because we use 3 datasets which contain 3 different difficulty levels. And we do the pilot study before we conduct the formal user study. And we average the time from the pilot study. Then I think the 5 seconds may be the average.
Okay.
So if the too short, if less than 5 seconds, that may be too quick. But if longer than 5 seconds, that may be not necessary. So we finally decide 5 seconds based on our pilot study result.
Thank you.
Perhaps I'll ask one more if, while we wait for the audience to think about some more questions. You did point to that fact in your very last slide, but I'm wondering, what do you think the impact of the expertise level of the labeler would be on this, right? You might have someone that's, for example, in your last data set, might actually be aware of these symbols. Might be easier for that person to label these more complicated examples, as opposed to like a newcomer to that language. How do you think this would interplay with the style of labeling?
The reason why we choose the Kusushi MNIST dataset because it is difficult even for the native Japanese. And actually, what we found is different people, they may feel different for the data difficulties. So, sorry, can you?
I'm just wondering, maybe there's like this 2D axis, right? Where on one dimension, you have the style, whether you're doing it fast or slow. And the other dimension would be the expertise level of the labeler, right? So it feels like there's this 2D space of labeling, labeler styles or persons.
Oh, yes, that should be interesting.
We do have a question on Discord, so I'll read it out loud for everyone. Do you think the problem with fast labeling is related to UI? And how to make sure such interfaces for datasets with lots of classes? So how can you scale this up to more than 10 classes? Or is it even possible?
It may be possible for the future study, but in our current study, we just want to simply prove the concept of different labeling style. So now we kind of prove this concept. So maybe in the future, we can use this concept for more labels, something like this.
But do you think like a fast labeling style could also apply to, let's say, ImageNet that has 1,000 labels?
Yeah, yes. For example, we can decide different layouts for different labeling style. But I don't have a clear idea now. But yes, maybe now it's just for user interface, but maybe we can think about different workflow. For example, label quickly could be they can select a label, but they cannot change the answers. But label carefully, maybe they can select the labels, and then after selecting some labels for several images, they make and return and change the labels. So different user interface or different workflow.
All right. Well, thank you very much for your answers, and thanks everyone for the questions. Let's move on to the second talk of the session that is titled Face UI, Leveraging Front-Facing Camera Input to Access Mid-Air Spatial Interfaces on Smartphones. The authors are Tuan Vo, Mariam Janat.
Hello everyone, my name is Tuan Vo. I am an undergraduate at the University of British Columbia, Okanagan. Today I'm going to present to you a paper titled Face UI, Leveraging Front-Facing Camera Input to Access Mid-Air Spatial Interfaces on Smartphones. This work is done in collaboration with Mariam, Dr. Alstrom, and Dr. Hassan. Now, when using a smartphone, people typically hold the phone in front of their face to easily access on-screen content. So this enables the front-facing camera on the device to track the spatial location of the phone relative to the user's face. We can further use this spatial information to place virtual interfaces into the mid-air space, where users can move the phone in the space to access the interfaces. Based on this idea, we present Face UI. It's a novel strategy to access mid-air face sensor spatial interfaces with off-the-shelf smartphones. Face UI uses the smartphone front camera to track the phone's mid-air position relative to the user's face. This self-contained tracking mechanism leverages the empty mid-air space in front of the user to accommodate virtual windows, in which the user can browse through different items by moving the phone in the space in front of their face. So we inform our implementations of Face UI by first studying essential design factors. We conducted 3 studies as follows. In the first study, we explore suitable phone-to-face distance and direction for accessing virtual UIs in the in-air space. In the second study, we identify suitable viewing angles for browsing and inspecting content that reside in the in-air space. Based on the results of the first 2 studies, we'll design Face UI and compare its performance with the traditional touch input for an analytic task where users are required to browse a set of calendar events before reaching a decision. Now, I'm going to briefly talk about a few prior work that are related to our work. So, prior research have explored ways to extend smartphone input capacity by shifting the interactions space into empty inner space surrounding the user body and their mobile devices. So for instance, virtual shells investigate accessing virtual items that are located inside half a sphere in front of their body. Similarly, AD-Bind investigated leveraging the mid-air space around the smartphone for accessing on-screen content. Zha and colleagues use a combination of facial movement, device motion, and touch for designing a face-centered interaction technique on smartphones. To our best knowledge, ways to leverage face-centered in-air spaces to access virtual user interfaces with off-the-shelf smartphones have never been explored before. So we started with developing a self-contained smartphone applications to track position and orientation of the smartphone relative to the user's face with front-facing camera. We use face detection API from the Google ML Kit. Among available face tracking related measures, our software relies on yaw, pitch, and distance data. We use this information to spatially track the phone in front of the user's face. Now, we started our explorations by investigating the comfortable phone-to-face distance while accessing the UI in both horizontal directions and vertical directions relative to the user's face. We observed that the participants are faster accessing items in horizontal direction over vertical directions. From subjective feedback, we found the participants prefer holding the phone in close distance than far distant. With another user study, we explore suitable viewing angles in both vertical and horizontal directions, where users are comfortably view and access on-screen items on smartphones. As you see here, we place the targets in different horizontal and vertical angles, where users are required to move the phone to the target angles and perform counting tasks. With the target angles for each direction, we see that the participants' performance degrades significantly at the highest angle in each direction. We also observe that accessing the screen content virtually is slower when the phone is positioned in the up direction than in any other direction of inner space. Now, using the findings from two previous studies, we evaluate practical usage scenario using Face UI, where users are required to browse multiple windows for retrieving information. Consequently, we'll design a calendar app to compare the performance of Face UI with the traditional touch interfaces. Now, with the traditional touch interface, the task involves selecting date and inspecting several events on that date. This inspection requires users to switch back and forth between lists of events and the detailed view. With Face UI, we leverage the empty mid-air space in front of the user to accommodate detailed view. The user can access the details on the events on the detailed view by simply moving their phone in mid-air rather than touching the screen. Our study results show that participants are significantly faster with browsing information using the Face UI than the traditional touch input. We believe this is primarily due to the fact that Face UI enables quick retrieval of virtual UIs by moving the phone, whereas touch interfaces requires user to switch in between windows, tab, swipe, which is known to be costly. Now, to demonstrate how face-centered spatial interfaces can be used in off-the-shelf smartphone, we show two applications here. First, Face UI Image Browser loads the images onto the inner space in front of the user into a grid. User can browse them by moving the device along horizontal and vertical directions. Second, we integrated Face UI into a chat interface for user to scroll through the messages by moving the phone vertically. Now, we summarize and present our key findings at design guidelines for designer to build interfaces similar to Face UI. We recommend designer to place UIs in the mid-air space within 40 centimeters from user's face. In addition, participants reported difficulties accessing items in the up region. Thus, limited or no items should be placed in this region. Results from our study suggest placing items between 40° left and 40° right in the horizontal direction, between 20° up and 30° down in the vertical direction. We also suggest that designer consider using mid-air space to place UIs to perform any browsing intensive tasks with Face UI enabled user interfaces. Now that we show Face UI is a promising solution to leverage mid-air empty space in front of the user for browsing on device content with off-the-shelf smartphones. Thank you for listening. I'm open to answer any question that you might have.
Thank you for the presentation. Do we have any questions from the audience or from Discord? Right in front.
Good. I wonder about the difference between using the face UI that you present and just the accelerometer or gyroscope in the smartphone, and whether there's an accuracy difference or you think there's another difference that we should be paying attention to.
Hi, thank you. That's a very good question. We actually have not considered those sensors in the phone yet because we are primarily using the front camera. So in further work, we'll integrate those into our research and see if they're in the performance difference. But right now, we'll primarily focus on the front camera.
Okay, thank you.
Thanks.
More questions? I'll ask one in the meantime. I'm wondering whether whether the users actually found that the interface to be preferable over just the touch interface, because I think you showed that it was actually helping them accomplish tasks faster. But I'm wondering whether you asked them like if they preferred it or if they liked it.
Yeah, we actually do like a follow-up survey for any participant following the comparisons between the Face UI and the traditional touch screen, and some show some concern, but and some fatigue, arm fatigue and eye fatigue during the trials, but overall the experience was that they find it's beneficial to them to do the browsing test, but I think because the technique is quite new, so it raised some I would say early concern on the arm fatigue and the time technique. Just that.
Thank you.
Yeah.
Anyone else? We do have one over here on the left.
Hi, thanks for the presentation. Something I was wondering is if this kind of interface, did it lead to your users dropping their phones more often? Because personally, I thought that would affect me.
For what we observe, we don't really have a case of drop in any phones, but it's just only much of an arm fatigue. That's it. But
okay, good to know.
Thank you for asking.
Thank you.
It would be nice to get a new phone, isn't it? So it's nice to drop every time.
Perfect excuse. All right. Thank you again. We'll thank our speaker again and move on to the third presentation of the session.
Hello.
Titled Promoting Feature Awareness by Leveraging Collaborators' Usage Habits in Collaborative Editors by Emmanuel Giannakis, Jesselyn Elvina, Andrea Bunt, Parmit Chilana, and Joanna McGrinier.
I'm Emmanuel Giannakis, and today I'm going to present our paper, Promoting Feature Awareness by Leveraging Collaborators' Usage Habits in Collaborative Editors. This work was done in collaboration with Jesselyn Elvina, Andrea Bunt, Parmit Chilana, and Joanna McGrinier. Feature-rich applications offer hundreds, if not thousands, of commands to help the users to complete their tasks. For example, Photoshop has more than 160 commands available to help users, and although offering many commands can be beneficial to the user, They still have to identify which commands they should use to complete their tasks more efficiently. Therefore, a challenge that modern design faces is how to help users identify the commands that are relevant to them. Prior work has offered various solutions to help users identify relevant features by leveraging other users. On the one hand, there are designs that leverage feature usage of the broader user communities, like community commands, which captures all of those who use a specific piece of software, or Skillometer that focuses on users in the same organization. On the other hand, they are leveraging peer-to-peer interactions to offer more localized support. But to our knowledge, there has not been yet any prior work on the space in between. What about the user's closest collaborators? The user's collaborators may be the people who are the most relevant to leverage knowledge from. Indeed, users often rely on their colleagues to discover relevant features by observing them over the shoulder or by directly asking them for help, usually in a synchronous, co-located setting. With the increase of remote work over the past few years, and especially during the COVID-19 pandemic, in-person interactions are far less frequent today, leaving fewer opportunities for feature discovery among colleagues. And therefore, we wondered, how could a user leverage a colleague's software knowledge when working in asynchronous settings without having to switch from one application to another? And in particular, we explored how can we design systems that help the users become aware of relevant features based on the collaborators' usage habits. To answer these questions, we first generated 5 design dimensions to explore the design space of promoting feature awareness by leveraging the user's collaborators' actions. We then used the design dimension to generate 5 design concepts, which we used in an elicitation study to better understand the user's preferences. To generate the design dimensions, we clustered the insights of the literature review, our own experiences, and an informal formative study. The formative study's goal was to understand how users currently learn from each other when collaborating remotely, and to gather some initial thoughts on how raising feature awareness based on their collaborators might affect their current practices. I'm not going to discuss the findings of the study, in part because of some overlap with the elicitation study's findings. In the end, we identify 5 design dimensions. For example, one design dimension is the specificity of comparison. This dimension explores the different ways that prior work has compared the user's actions to the user community. On the one end, we have explicit comparison, where the user's features usage is explicitly compared to their collaborators, for example with the use of visualizations like a bar chart. On the other end, we have implicit comparison, which is a much more subtle comparison, and for example here the system highlights features that it thinks a user might want to use based on what other similar users use, but there is no specific details given about their collaborators' features usage. Another one is the goal of feature discovery. This dimension comes from an insight of our data collection and deviates considerably from prior work, which primarily focused on learning new commands. We found that users value raising feature awareness based on their collaborators, not only because they can discover new commands, but also because they can help them keep a consistent formatting across the document, even if the commands were already known to them. We designed 5 design concepts for promoting feature awareness based on the user's collaborators' actions that differ among these design dimensions. We use as inspiration existing tools that raise feature awareness, which we redesigned to better fit our context. So now let's see the 2 design concepts which participants of the elicitation study liked the most. The most popular concept was Collapatina. Collapatina will highlight the toolbar commands that the users most frequently use with a yellow color, the commands that the user collaborators most frequently use with a purple color, and the commands that the users and the collaborators most frequently use with a red color. The second most popular concept is Newsfeed. Newsfeed allows the users to follow specific collaborators and see which commands they used recently. By default, they will see the commands that the collaborator is using today, and in particular, they will see the name of the command and how many times the collaborator used it today. The user may also like a specific command if they want to, and they can also ask follow-up questions or see what others have already asked about this particular command. We use the design concepts as probes for an elicitation study with 18 participants to understand where the participants' preferences lie within the design space. All participants reported they use collaborative editors to collaborate with others at least a few times per week. And they came from different backgrounds such as social workers, designers, teachers, and developers. During the session, we showed them the 5D video concepts, and for each concept we probed them on their initial impression and asked them to think how they would use the prototype in their everyday life. In the end, we asked them to sort the concepts in terms of preferences. And from our analysis, several themes emerged across the design's concepts. Let's focus on two themes in particular. The first one is raising feature awareness based on the user's collaborators would help users converge on software usage practices. The participants commented on the usefulness of the concepts to identify similarities and differences in features that the collaborators use to produce a consistent style. For example, PH said, "When I used to work on PowerPoint, we would usually be texting or calling each other to stick to this particular layout. Instead of doing this communication outside the platform, I think within the same platform, if we could see this information, it could be more efficient." The second thing I'm going to discuss is detailed information about collaborators' actions could make users feel micromanaged and self-conscious. Some of our concepts, like Newsfeed, show detailed information about who used the feature, how often they used it, and how recent. According to our participants, this level of detail could be useful to them to understand whether the highlighted feature is relevant to them. On the downside, this information could also make users feel micromanaged and self-conscious. For example, P7 commented, "When I think about seeing collaborators' names using it, I feel like I'm a very picky production manager who is trying to micromanage people and make them work faster." We found this insight very interesting as it highlights the trade-off between the availability of detailed information versus feeling micromanaged and self-conscious. We think that striking the right balance on how to present this information is an important design challenge. And therefore, we propose to expand our design space by adding detailed feature usage information as an emerging design dimension. At one end is high level of detail, where designers could use precise numbers, dates, and names to reveal collaborators' usage habits, and on the other end, we have low level of detail, where designers could use language that describes the behavior but avoids specific numerical values. Finally, to further probe on the participants' preferences for each design dimension, we went through each transcript to specifically look at comments related to design dimensions. We then positioned these comments within the design space. We observed that participants' preferences for some design dimensions leaned towards specific ends. We observed that participants had a strong preference for implicit comparison, meaning that they preferred systems that highlight relevant commands rather than directly compare their actions to their collaborators, possibly because this could make them feel self-conscious. We also observed that participants expressed a strong interest in using these tools to both find new features and to help them and their collaborators adopt common software usage practices. And we also observed that participants preferred low level of detail when it comes on recency and frequency of feature usage, but they were more comfortable with a system that provides more detailed information about which collaborators use the feature. To sum up, our work shows that promoting feature awareness based on collaborators' usage in shared editors have a rich design space and is a promising direction for supporting people in learning and using feature-rich software. Thank you very much for your attention, and I'm looking forward for your questions.
Thank you for the presentation. Do we have some questions in the audience? We have one just right here in the middle.
Hi, thank you for your presentation. My question is, were the hints sort of contextual based on what the user was doing, or was it sort of, regardless what I'm doing, here's what other people did? Or was it sort of like, people use this feature after making a selection, or people use this feature after using that feature?
So these were beta concepts, so there was not necessarily logic behind. The idea is that it wasn't based on what the user were doing. It was based on what were the most frequently used commands that the collaborators were using in this specific document.
Okay, and was there any feedback about the relevance of these? Basically saying like, okay, my collaborators click on this button all the time, but I don't care.
The feedback they found, most of the users found it, most of the participants found this information relevant, especially if the collaborators were working on the same tasks as they did. So, for example, some participants were saying that if I am working on the visual elements of a document I don't know, like a report, then I would like to see what the collaborators that they're working also on the visual elements, rather than the collaborators that perhaps were working on the actual text.
Okay, thank you.
I'll ask a question. I'm wondering whether you saw that this, the use of the system could actually help perhaps people be more proficient at the task using the tools. But do you think that this would also decrease the number of social interactions they would have with coworkers in a remote setting, in the sense that they don't need to reach out to someone to ask for help anymore because the interface is providing it to them? Do you think that could act as like a downside to using this kind of feedback?
So our study didn't focus on that, so I don't have enough data to reflect on our current study. But my feeling is no, in the sense that I've seen that a lot of participants were more than willing to ask follow-up questions once they identified relevant features, especially the ones that they were not straightforward, or when they saw the potential that they could see a sequence of features, because some of our concepts was offering also that, in order to understand why they were going through a specific path, for example, why they use a specific sequence of commands, for example, to complete a task and not another sequence of commands, which also it's kind of an opportunity of efficiency as the participants saw it, how to become more efficient. And so I think that there is a potential to have a more optimized communication, let's say, to focus on the task at hand and to minimize the interruption. I can see how what you just commented could be also a potential drawback, but it will need to be kind of in a future study to see how this could be affected, how this can affect the collaboration.
Right, thank you. Any last question? All right, well, in this case, let's thank our speaker again.
Thank you very much.
And we'll move on to the fourth and last presentation of this session, titled Dual Label, Secondary Labels for Challenging Image Annotation by Chiaming Chang, Yihei Shi Yang, Haoran Xie, and Takeo Igarashi.
Hello, everyone. This is Jiaming Zhang from the University of Tokyo. Today, I will talk about our study, Dual Label, Secondary Labels for Challenging Image Annotation. This is the problem we aim to solve in this study. The problem is it is very difficult for non-expert annotator to select an appropriate label for an image when the annotation task is difficult. For example, when the two labels are too similar for an image, it is very difficult for non-expert to select only one. So in such cases, it may be easier for a non-expert annotator to select multiple likely labels than to select a single label. And the multiple labels may be more informative in the training of a classifier because the multiple label can contain a correct one, even when a single label is wrong. In this study, we propose dual label and image annotation tool that allows annotator to select a secondary label for an image when they feel difficult to select a single appropriate labels. If the annotators are confident with only one label selections, they can only select a label as primary labels for the image. However, if they are not confident with a single label selections, they are allowed to select a secondary labels. They will have a secondary choice to select one more labels. Here shows an example of a usage scenario. The annotators is unsure which dog breed is most appropriate label for the target images. The annotator think the answer may be this label or this label. So the annotator can select one as a primary label and another one as a secondary label. So this is the main concept of the dual labels. And our hypothesis is the dual label can make the annotation process more easy because user can select two, so they don't need to spend time to consider if they only can select one. And the dual label can improve the classification accuracy of trained models by using the dual label data. We run a user study to compare our proposed dual label approach to a traditional single label approach for an image annotation task with different levels of image difficulty. Single label means that user only can select one label for the image. And the dual label means that the user are allowed to select a secondary label if needed. We use dog image dataset from ImageNet, which contains 120 dog breeds. For the image annotation task, we manually create two datasets with different data difficulties. One is difficult dataset, one is the easy dog dataset. The difficulty levels of the selected dog breeds are based on the result of the Stanford dog image classification. A difficult dog breed means that the classification accuracy was low for the dog breed. "24 participants were invited to join our user study, and their task is to label 120 dog images, 60 images by single label approach, and 60 images by dual label approach. This table shows the distribution of the annotation tasks and the data sets for the participant. Here shows a demo video of how an annotator used the dual label approach during the image labeling task. Okay, so for example, they are not quite sure about this image. They are thinking this label or this label, so they can select one as a primary label and another one as a secondary label. So, and in the user study, we measure task completion time, accurate annotation accuracy, and number of assigned labels of the labeling task completed by the participant. The result of the test completion time shows that dual label approach can significantly reduce test completion time in a difficult dataset. However, there was no significant difference between the single label and the dual label approaches in the easy dataset. However, the result of the annotation accuracy shows that dual label approach cannot improve annotation accuracy in both easy and difficult dataset. In addition, the result in the number of assigned labels shows that dual label approach can collect more labels, can collect more secondary labels for images. So we can see in the single label approach, we only can collect one label for an image, but in the dual label approach, we can collect more labels for an image. And this helps machine learning in image classification. I will show the machine learning result later. We also analyze the learning effect during the image annotation task. The result shows that the dual label approach can improve annotation efficiency when the images are difficult. Our questionnaire result shows that dual label approach can reduce annotators' subjective feeling of difficulty. And the dual label approach was more helpful than the single label approach. And the dual label approach was more efficient than the single label approach. This is the machine learning result. It shows that dual label approach can significantly improve the accuracy of image classification in a difficult dataset. However, there was no significant improvement between the single label and the dual label approaches in the easy dataset. There are three contributions from this study. First, dual label and no-fee annotation tools that allowed users to assign a secondary label to a difficult image classification task. Second, a user study compared dual label to a traditional single label approach, and it shows the benefit of the dual label approach in challenging image annotation task. Third, a machine learning experiment. It shows that dual label approach could significantly improve the accuracy of image classification. Thank you much. Thank you very much. Any questions?
Thank you, Qiaming, and nice to see you again. Are there any questions in the audience? I can start with one. I'm wondering, in your machine learning experiment, how did you make use of the two labels? Was it like you were training the model to predict either one of those or both, or how did that work?
So in the machine learning, we give different weight for different labels. For example, we give the primary label the 1 and the secondary label the 0.1. But actually we test 0.1, 0.2 until 0.9, but we didn't see big difference. So finally we choose the weight as the 0.5 for secondary labels and the weight 1 as the primary labels, and we train the data collected from our user study.
All right, thank you. I guess I'm wondering then, did the users have difficulty in choosing like the primary label? There's a secondary, they could swap them. Would it, this distinction of having the one I'm most comfortable with or most confident in and the second one useful, or would it have been, I don't know, better in some way to just say choose two or choose however, maybe more than two, So it seems like you have this kind of rigid way of asking for two labels.
I think the main benefit of the two labels is if the user are considering two labels, two possible labels, they don't need to spend much time to think if they only can select one. So this is the benefit. It can speed up the manual image annotation process. So this is one good part. And even the second label, it be the additional data for the machine learning training. So there may be another benefit for machine learning. So this is our main concept.
Mm-hmm. But there's a question in the middle, right here in the front.
All right, so I have a question related to that in terms of confidence. Did the participants have did they express their levels of confidence? We've used a confidence rating when it comes to labeling, so that it's better to understand how they're feeling about it, because it doesn't really matter whether you make one or two or three or however many labels. If you're not confident about that label, then that changes, the accuracy of it, I suppose, and perhaps the weighting that you would give to it.
So in our study, we defined the primary label they feel is high confidence. And we define the secondary label is they feel this label is low confidence. So that means one is high confidence. The high confidence label is the primary label, and the low confidence label is the secondary label.
Right, but did they give you a level of confidence? Because the first one may be higher than the second one, but it still may be pretty low, which would make a difference if they were 100% confident versus 20%, 10%, that kind of thing.
Yes, this is interesting, but we didn't analyze this part. Yes, we only asked them to compare which one is high, which one is low, but maybe sometimes both are very low and both are very high, I think. Yes, this could be interesting part.
Right, just following up on this, perhaps. It could also be that the second label, maybe the first label, the person is super confident that it's this exact breed of dog and would not need to have a second label, in which case perhaps having a second label, which will be wrong because the person is very confident about the first one, would be adding noise to the data set. Do you think that's likely?
So in this case, they are only allowed to select one label.
But in the dual label case, you could still be very confident that there's this single label. I know it's for sure this kind of dog. I have one at home, whatever. I don't need to have a second label.
Yes, so then they can only select one in the dual label.
Could. Okay.
Yes, they could.
Great. Okay. All right, well, let's thank our speaker again.
Okay, thank you.
And this concludes our second session of the morning. Now it's time to go to lunch, and we meet back here at 2 p.m. for the keynote by Jerne.
Hi, everybody. Just before everybody takes off. So lunch, for lunch, you're on your own, but there's plenty of restaurants in the vicinity around the conference venue. So there's restaurants out here on Notre Dame. There's restaurants on Peel. There's an Amir across the street, Subway. There's some very nice deli counters at the grocery store here, further down Peel. There's some nicer restaurants as well down at the end of Peel. So I recommend finding a group to go to lunch with and then heading out and come back here at 2 p.m. Thanks.